Next one, fog and cloud. Because of fog and cloud, what is the attenuation? Medium fog, heavy fog. All the natural factors, whatever we have, will contribute to loss. They all absorb your signal and contribute to loss. Now, atmospheric gases. Because of gases, what is the loss? You can see that atmospheric gas absorption is there. It is frequency dependent. It is having a varying structure. And finally, you are going to add everything and say what is the total propagation loss. This is the total loss at 77 gigahertz. At 77 gigahertz radar application, if I'm going to use, this is the path loss. So for individual loss, I am taking it and plotting. First one is free space, then you have rain, fog, and atmospheric absorption by gas. Now we are going to see the propagation delay and path loss. I'm going to send a signal. You see here what is the propagation delay, and you are going to, this is the property of your channel. Okay, so I am going to plot the received signal. You're simulating the received signal, you're finding the total loss, and you are analyzing the power. This is the analysis power you get, 289 dB loss you have. Next one is multi-path propagation, what you have in wireless communication. I'm just running each section separately so that this is your direct ray, this is your reflected ray. Direct ray will always have a very high power compared to the reflected ray. Okay, I'm assuming a two-ray model. Okay, same way for direct ray and reflected ray. Here, I am going to have the antenna unit a bit taller. The direct ray will be reaching the less power. Reflected ray will be reaching with a larger power. That is also possible. Okay. Next one is fading. We are going to see what is the mobile height versus channel loss. When the mobile height, for what mobile height, what is the channel loss you are going to observe. So accordingly, you can set the mobile height so that at the least height, what is the minimum loss you have, you can fix that as your design parameter. Now I am creating a two-ray model and I am visualizing the two-ray model. Narrow band and wide band. For the narrow band and wide band system, I want to visualize the two-ray model. If for narrow band systems, the channel loss is very, very high. For wide band system, the loss is very, very less. As the antenna height is increasing, you can see the loss is reducing. Yes, that is the expected behavior in the RF propagation. So you can design what type of medium you have, what all types of losses you have. So you can fix all those things and you can design your RF propagation mechanism for the medium.